Since today is Father's Day, it is only appropriate that I start with a dad joke. What do you do when you see a spaceman? You park your car. Ugh, terrible. Today's fun fact actually starts with a news report from the Vatican. They were the first to get it to my inbox, but several similar news announcements soon followed. NASA's James Webb and the Hubble Space Telescopes joined forces to study Terzan 5. Terzan 5 is approximately 20,000 light-years away, give or take 2,000, in the constellation Sagittarius. It contains about 2 million times the Sun's mass, packed into a stellar system only a few tens of light-years across, making it one of the most massive and densely populated globular cluster-like systems in the Milky Way. Astronomers already knew that this star cluster was unusual in that it contained two stellar populations of very different ages. New research has found strong evidence for two more stellar populations, one that formed 3.8 billion years ago and another only 2.5 billion years ago. The research team also was able to determine the ages of the previously known stellar populations with unprecedented precision, finding that they formed 12.5 billion and 4.7 billion years ago. So far, distinct stellar populations billions of years apart have been discovered, a bit like extreme urban sprawl on a galactic timeline. Now, get ready to add a fairly new term to your space vocabulary, BFF. This finding proved that Terzan 5 is not a globular star cluster as originally classified. Instead, Terzan 5 belongs to a new category known as a bulge fossil fragment, BFF, a self-contained, self-enriching stellar system with multiple star populations of different ages and with different iron abundances. This image shows an oblique view of our Milky Way galaxy, showing the positions of our Sun and the Terzan 5 cluster. Terzan 5 was discovered in 1968 by Agop Terzan, a Turkish-French astronomer of Armenian descent. And the intense, beautiful photos of this galaxy 20,000 light-years away just keep coming. This one is from the Webb NRI cam, and this next one is from the Hubble Space Telescope. So Terzan 5 may just become a lot of astronomers' new BFF, best friend forever. And now on to a new headline. A space telescope is falling out of space. NASA has a daring plan to save it. NASA's Swift Space Observatory is falling out of its orbit. For over 20 years, NASA's Swift Space Observatory has been conducting prolific science in orbit, hunting for signs of gamma-ray bursts, the most powerful explosions in the universe. Now it's falling to Earth, doomed to a fiery death by the end of the year as its orbit decays. I have to confess that I had no memory of the Swift Space Observatory, but perhaps this name will be more familiar to everyone else. Neil Gehrels Swift Observatory. It was launched in 2004, well before Sunday Night Astronomy show Fun Facts existed. It is a 3-telescope observatory for studying gamma-ray bursts and monitoring the afterglow in X-ray and UV visible light at the location of a burst. NASA's plan is bold and unprecedented. It has a daring rescue mission in the works, something never before attempted in space, called the Swift Boost mission. The endeavor calls for an untested spacecraft built by the Arizona company Catalyst Space Technologies to rendezvous and dock with Swift, something the observatory was never designed to do, before the observatory falls back to Earth. Link aims to become the first private spacecraft ever to capture a robotic satellite operated by the U.S. government. In this picture, engineers from Catalyst stabilize their Link robotic servicing spacecraft as it moves into a vibration chamber at NASA's Goddard Space Flight Center. This was on April 15, 2026. Doing so will not be easy, especially since it's unclear exactly where Swift will be in the coming months. That's because Earth's atmosphere, and therefore the drag it imposes on orbiting spacecraft, is not static. Our blanket of air expands when the sun is active and contracts during times of solar quiescence. This graph is showing actual and predicted altitudes for NASA's Neil Gehrels Swift Observatory. The thick orange line shows Swift's mean altitude from November 2025 to early May 2026. The curves in various shades of green show altitude forecasts generated by the Space Science Mission Operations Team at the agency's Goddard Space Flight Center. So, to all my BFFs out there, here's something to watch for soon. The Link robotic spacecraft is scheduled to blast off to rescue and boost the orbit of NASA's Neil Gehrels Swift Observatory on June 27, 2026, launching aboard a Northrop Grumman Pegasus XL rocket from the Ronald Reagan Ballistic Missile Test Range on Kwajalein Atoll. Link will take 1 to 2 weeks to catch up to the Swift Observatory, followed by a commissioning period before attempting capture with its robotic arms. The estimate is 9 months to completion. You can track updates and mission milestones on the NASA Swift Boost mission page or view imagery and press kits via the NASA Science Swift Media Resources Hub. This will be a fun space mission to follow.